Okay, hey, welcome back to Moose and Chemistry. Today's lesson is Dalton's atomic theory explained. So what we're going to do is we're going to go over the 5 postulates, or the 5 things that Dalton said that he believed to be true about atoms. Well, first of all, Dalton created his atomic theory. His name was John Dalton, and John Dalton was an English school teacher. And Dalton created his atomic theory in 1808. Now, he wasn't the first to propose atomic theory. There was this Greek guy who lived thousands of years ago named Democritus. And he's the one who came up originally with that all things are made up of atoms. All right, anyway, and we'll talk about that on another lesson. So, first thing Dalton says is that all matter is composed, which is a fancy word for made up of, extremely small particles called atoms. Now, you have to remember that in 1808 they did have microscopes, but these microscopes couldn't see atoms. So he said that all matter is composed of extremely small particles. In other words, particles that you can't see with your eyes are called atoms. Okay? So the second thing that Dalton stated was atoms of a given element are identical in size, mass, and other properties. Atoms of different elements differ in size, mass, and other properties. So, in essence, what he's really saying is this, that gold is gold, silver is silver, but silver doesn't look like gold, or doesn't have the same properties as gold, or sodium doesn't have the same properties of, say, carbon. So that's what he's really saying. So he's saying that all atoms of carbon are the same. Okay, and this is atoms, of course. All silver atoms, we'll call it all silver atoms, are the same. But carbon atoms are not the same as silver atoms. And size, color, different, mass, and other physical properties. All right, so let's get rid of all that there real quickly because we need the space. Guess I'll have to get my eraser out here. I don't like using it too much because it's not very big. All right, as an eraser goes. So now, let's look at the third one. Atoms cannot be subdivided, created, nor destroyed. Now, guys, in 1808, we didn't have thermonuclear weapons. So, in 1808, that was true. But remember that the atomic bomb takes uranium or plutonium, whatever they're using for their fission or fusion devices, and it actually converts matter into energy. So once matter becomes energy, it no longer has any properties of like it takes up space and has mass because it becomes pure energy. So we know that now Dalton's theory on number 3 is no longer correct in the world. Okay, so 4. Atoms of different elements combined in simple whole number ratios. Wow, that's a big saying. To form compounds. Okay, what does this really say? Okay, H2O. That's a 2-to-1 ratio. Lithium fluoride, 1-to-1. These are simple whole number ratios. There are no halves. They're the lowest possible relationships between both atoms. Okay, let me go ahead and erase that real quickly because I need the space. And that's still true today. So that's not an issue. All right. Last but not least, Dalton's final thing said that in a chemical reaction, or in chemical reactions, atoms are combined, separated, or rearranged. Okay, what that means is this. Okay, for example, sodium plus chlorine yields sodium chloride. So we put a 2 there and put a 2 there to balance it. So when atoms are combined, they make completely new substances. So let's erase that real quickly. Also, it says that it's separated. All right? So when we talk about being separated, we'll do something simple again, like H2O separates into hydrogen gas plus oxygen gas. So we're going to put a 2 there and a 2 there, and it's balanced. So that would be decomposition. Or rearranged. Well, let's look at that one real quickly. If I've got enough space here, we'll just try and do something pretty simple. We're going to say, okay, let's make this really simple. Lithium fluoride plus sodium chloride yields lithium chloride plus sodium fluoride. So there's an example of being rearranged. All right, so you guys have an awesome day, and we look forward to seeing you again on Moose Chemistry. Take care.